Hello, calculus students. I'm going to do some of these problems from, this is a 2016 practice test. You would have 60 minutes to do the 30 problems in this. I'm going to try to go kind of fast, but I'm going to try to talk about anything that needs to be talked about by way of review. Alright, this is just a straight up antiderivative definite integral problem. So let's see, the antiderivative of that would be x cubed over 3 minus x squared. That's just reverse power rule. Not a whole lot of calculus that's much easier than this. So I plug in the 3. That's 3 cubed is 27 divided by 3 is 9 minus 9. And then, I don't know if you can hear that, it's raining real hard outside. Sounds nice. And then I plug in the negative 1. Negative 1 cubed over 3 is negative 1/3, right? A negative cubed is still negative. Minus negative 1 squared is 1. So that looks like a positive 4/3. This is no calculator, the 1 through 30 part, so you do have to be able to do math sometimes in math class. Next one, looks like we're finding a derivative here and then plugging in 2, and it looks like it's a product. So this is to see if I know product and also some chain rule. So I'm always thinking about that when I'm running through one of these, that what the person who wrote this question, like what are they trying to see if I know? Derivatives, so they're checking to see if we know our rules. So the derivative of the first would be e to the 2x times 2, the times 2 because of chain rule, times the second, plus the first times the derivative of the second. And that's just 3x squared. I was going to write plus something, but that's plus nothing because the derivative of 1 is 0. So there's my derivative, right, using the product rule and a little bit of chain rule right there when I had to take the derivative of that. So what's f prime of 2? It's e to the 4 times 2. I'm not going to try to simplify too much too fast. 2 cubed is 8 plus 1 is 9 plus e to the 4 times 3 times 2 squared is 4 times 3 is 12. So it looks like I've got 18 e to the 4th plus another 12 e to the 4th, which is 30 e to the 4th. Let f be a differentiable function such that f of 2 equals this and f prime of 2 equals negative 1/2. What's the approximation for this? Using the line tangent to the graph at x equals 2. Tangent line. I know how to make the equation for a tangent line. I need a point, which is the point 2, 4. There was a little flash of lightning here, waiting for the thunder. Where is it? And then the slope is this. So my tangent line is y minus 4 equals slope times x minus 2. So if I want to use that tangent line to approximate this, I just plug in the 2.1 in here and figure out what y is. So y is equal to, I'm going to go ahead and move the 4 to the other side, 4 minus 1/2 times 2.1 minus 2 is 0.1. Half of 0.1 is 0.05. 4 minus 0.05 is 3.95. And if you're like, what, I got to do that without a calculator? Yeah, you can write a letter to your congressman and complain about the College Board, but yes, you do. Let g be a function defined by this. How many relative extrema does g have? So vocabulary, this is back to Chapter 5. Relative extrema means maxes and mins. So how do we find those? We take the derivative of this and we set it equal to 0. Factor out of 4x squared. It's called algebra plus 3. And where is this equal to 0? It's equal to 0 when x is equal to 0, or when x is, equal to negative 3. I'm oopsing because I should have left myself more room over there. Now, relative extrema, that's maximums and minimums. That only happens when you get a sign change in the derivative, when it goes from like increasing to decreasing. It could possibly happen where the derivative's undefined, but that's not at play here. So the thing is here, this is always positive, so the sign only depends on this part. So when I'm below negative 3, it's going to be negative, and it's going to be positive, and then it's still going to be positive here. You can check numbers, plug them in if you want. So I only have 1. I only have a minimum going from decreasing to increasing here. I think the sucker answer is 2, because you're like, oh look, it's 0 and negative 3, but the 0 doesn't have a sign change. Number 5, the velocity of a particle moving along the x-axis is given by this. What is the average velocity of the particle from time t equals 1, time t equals 3? The average value of something, average value of, you could say some function, I'll write it in general, of some function f on some interval from a to b is equal to the integral f of x dx from a to b divided by how wide the interval is. That is from Chapter 7. That's fairly recent. It's a thing that you have to know. That's how you find the average value of a function. So you want to find the average value of the velocity? Sure. We just have to do the integral 2 minus t squared dt from 1 to 3 divided by how wide the interval is. So this right here is the antiderivative of 2 is 2t minus t cubed over 3 from 1 to 3, all divided by 2. So let's see, if I plug 3 in here, I'm going to move down to the bottom, give myself a little bit more room here. If I plug 3 in there, I get 2 times 3 is 6, minus 3 cubed over 3 is 9, minus, when I plug 1 in, I get 2 minus a third, and that's all divided by 2. That's negative 3. That is 5/3 right there, so minus 5/3 all over 2. Let's see, if I get that into thirds on the top, that's going to be 9/3, right? 3 is the same as 9/3, so negative 9, that's negative 14/3 divided by 2, which is negative 7/3. So that is answer choice C. Pretty heavy on the math, huh? In this particular practice test. On a certain day, the rate at which material is deposited at a recycling center is modeled by the function r. This is a rate. Remember that the integral of a rate is equal to the change in whatever the stuff is, the amount of stuff that the rate is modeling. Is measured in tons per hour, using a trapezoid sum with 3 subintervals indicated by the data in the table. What's the approximate number of tons of material deposited in the first 9 hours? Okay, so I just need to do a trapezoidal sum of this. So to do trapezoids, we do how wide is the trapezoid divided by 2, always divided by 2, and then I add up the 2 edges of the trapezoid. Next trapezoid, how wide is it? 5 divided by 2, and then add up the 2. How wide is this trapezoid? 2 divided by 2, and then those. Okay, more math. That's 115 plus 9 is 24 plus, this is 14. Half of 14 is 7 times 5 is 35. If you're like, yeah, I'm just going to do this with my calculator. No, you can't. This is a Practice for the AP test. I think it's 68. You got to practice the way you're going to have to do it. So I'm getting 68 there. If you're like, wait, I don't remember how to do that, then go back, review those notes. That's in early chapter 6, Area Approximation. What's total area of the regions between the curves y equals 6x squared minus 18x and y equals negative 6x from y equals 1 to 3? Well, this is a parabola, like upward opening parabola, and this is a line that goes down like this. So I'm pretty sure, without having to graph these, that this is on top of this. And I'm pretty sure that between 1 and 3, let's just do, so I'm going to do a little bit of algebra real quick here. Factor out a 6x, and that leaves behind x minus 3. So this is an upward opening parabola that crosses at 0 and 3, like this. And then the line y equals negative 6x. So do they intersect or not? I think I have to do that, right, to see if they intersect each other. So to see if they intersect, I would have to do that. And then add that over to the other side. 6x squared is equal to, minus 12x equals 0. Factor out the 6x again, x minus 2. So they intersect right in between. That is kind of mean, I think. That makes this problem a lot harder than it would be otherwise, because you have to do two separate integrals here. If they intersect at 2, that means you have to do the integral from 1 to 2 of, let's see, which one is going to be on top? They intersect. I think the line has to be on top first. So if I get a negative sign here when I do this area, then I just know I did it backwards and I can just flip my sign. So area between two curves. This one's on top minus this one's on bottom. Again, if I did it wrong, then I'll get this to negative sign and I'll just flip it. So, and then for the rest of it, I have to do the area from 2 to 3, and then they switch places. Now this is on top, and this is on the bottom. Right? So that's a lot of work to get this area. We're probably moving, well, we might be okay. I think we're moving a little slow. I'd be getting nervous here if I was on number 7. But anyway, here antiderivative is minus x squared minus 3x squared. Oh, you know what? I should have just combined these. This is minus, let me do that real quick. I'm going to move down here again. So consolidating my first integral here, I have minus 6x plus 18x. That's 12x minus 6x squared. So my antiderivative there is going to be 6x squared minus 2x cubed from 1 to 2. And then when I go from 2 to 3, it's going to switch with the sign flipped. You can go through and do that math again, but it's just going to be the exact same thing, opposite sign. Think about why that has to be true. All right, so here, plugging the 2 in here, I get 2 times 4 is 24 minus 2 times 8, which is 24, minus, when I plug 1 in, I just get 6 minus 2. Oh, and note here, I think I did get it the wrong way around, because this is 24, this is negative 4. So that means when I decided which one was going to be on top, I decided wrong. So I'm just going to make the positive version of that. And then I'll do the same thing here. This should be backwards too, I think. If I got this one backwards, it means I had to get this one backwards too. So 2 times 3 cubed, that's 54, minus 6 times 3 squared, also 54, minus, plugging the 2 in, 2 times 8 is 16, minus 6 times 4 is 24. Interesting. And so that gives me 0 minus, that gives me 8 there, and that would give me 12. Yep, that's right. So just make sure you have the positive version of the area, and you'll be okay. So I'm looking at this like, why did this one come out to be negative and then this one was positive? That seems weird to me. Yeah, that's the right answer. So go back to here real quick, just check to see something. 2 from 1 to 3. Yeah, that's, I guess it's possible that what could have happened, this could have just grazed the parabola, and then I didn't need to actually split them up. But anyway, if you do split them up, and you make sure you're doing your absolute values, we did come out okay. All right, moving on. Number 8, the function g is defined by g of x is equal to x squared plus bx, where b is some constant. If the line tangent to the graph of g at x equals -1 is parallel, that means same slope, to the line that contains the points these, then what's the value of b? Well, what's the slope of the line that goes through those 2 points? That's just rise over run. So 4 minus -2 over 3 minus 0, that's 6 over 3. So the slope has to be 2. Okay, so what's the slope of this? Well, g prime of x would be 2x plus b. That's the derivative of that. And what they want is the line tangent to the graph of g at x equals -1. So when I plug -1 into this, when I plug g prime of -1 is -2 plus b. And that's going to be parallel to this, so that means it has to equal 2. And that means that b has to be 4. All right, 2 more we're going to squeeze into this video. This is one of the favorite types of functions of calculus teachers everywhere. If you have absolute value of a thing over that same thing, it causes there to be a jump in the graph. So if you think about the absolute value of x over x, these two things are always the same number, except that if x is negative, then this is the positive version of it here, and this is the negative version. So this expression is always equal to 1 if x is positive, or -1 if x is negative. All right? Like, think about plugging in different numbers there. Pause and think about that for a second if you need to. All right, it looks like this. If you plug in 1, it's equal to 1. You plug in 2, it's equal to 1. If you plug in 7, it's equal to 1. It's equal to 1 for any positive number. Well, when you plug in negative numbers, this makes it the positive version divided by the negative same number. That's equal to -1. And then they're saying at x equals 0, it's equal to 0. So it looks like this. And they want to know what's the value of this integral. You think it's non-existent? No, of course we can still do this. You could still chop it up into rectangles and do Riemann sum or whatever. So we're just going to do this. This is a very geometry kind of problem. It's going from -5 to 3. Remember, we're always doing area between the graph and the x-axis. So I got an area of -5 here, and I got an area of 3 here. So that's -2. If you find yourself doing area with an absolute value kind of thing, we don't have rules for that. You have to know what it looks like and do geometry. So 10, let g be a continuous function using the substitution u equals 2x minus 1. This integral is equal to which of the following? Alright, so if u is equal to 2x minus 1, then du is equal to 2 dx. So I would need a 2 in here, right, which means I would need a 1/2 on the outside. So the rewrite of this integral now looks like 1/2 times the integral of, I'm going to make these into u numbers, so plugging the 2 in here, 2 times 2 minus 1 is 3, and 3 times 2 minus 1 is 5, and then g of u du. Right, because this is u, and I slipped a 2 in there so that I could say, oh yeah, 2 dx is equal just to du. Right, and there's my 1/2 on the outside to balance it. So that looks like this.